Hi, I'm an old guy and I do maths. Today we're going to have a look at rational root theorem. Now, I've been asked about this a number of times, and reviewing the way that textbooks deal with it, I think I think a bit gets brushed over and it becomes quite confusing for some people. So I'm going to talk you through what I do and how I do it and why. Which sounds like rather a lot. So we've got a cubic here, 2x cubed plus 11x squared plus 17x plus 6. And I know the factors of this, so let's not pretend that I'm actually doing this, because I had to find one where we got a selection of factors and everything worked out evenly. So I actually started with the factors and multiplied it up. So what does rational root theorem entail? Well, basically what we're looking for is we're looking for a factor of this. Now, if you use the old method, or the standard method of putting 1, -1, 2, -2, 3, -3 into this, you might get lucky. I think that where rational root theorem really comes in is where we've got coefficients of x cubed that aren't 1. That's where I would be attracted to it. Anyway, so what do we do? Well, we take the factors of this number and the factors of this number. So we work all those out, and the factors of 6 plus or minus any of these numbers, 6, 3, 2, 1. And the factors of 2, 2 is a prime number, so pretty simple, 1 and 2, either positive or negative. And then what we do is we divide the top by the bottom. So basically we create a series of divisions using these as the numerator and these as the denominator. And this is what we get. We get plus or minus 6, so 6 divided by 1. 6 divided by 2 is 3. 3 divided by 1 is 3. There's a repetition there, we don't bother repeating. 3 divided by 2 is 3 over 2. 2 divided by 1 is 2. 1 divided by 1 is 1. 3 divided by 2 is 3 over 2. I may have said that. And 1 divided by 2 is a half. And because these are positive and negative, these too will be positive and negative. And what this does is it gives us a range of potential solutions to this. So then we use factor theorem. So we do get back to factor theorem. And I've done this with one example, which is negative a half. So why did I choose negative a half? Well, it's the smallest number, and so it's a place to start. But I'm also attracted to a half because of this. The factor that we're likely to get is going to be 2x plus or minus some, well, actually plus something, because everything in here is positive. So I'm attracted to this. I'm also slightly attracted to this. So I'm going to start here. Now, because this is positive, and because the factor that we're going to get from it will be in all likelihood positive, we're going to use negative a half. So we're going to put negative a half into this function, and this is what we get. 2 times negative a half, sorry, that should be cubed, plus 11 times negative a half squared, plus 17 times negative a half, plus 6. Moving right along, that tidies up to negative a quarter plus 11 over 4 minus 17 over 2 plus 6, and again that tidies up to 5 on 2. If you simplify this, you get 5 on 2, minus 17 on 2, which gives us negative 12 on 2, plus 6, which gives us 0. Right, so what does that tell us? Well, it tells us that 2x plus 1 is a factor. And how I get that from here is as follows. If I just do this in reverse, 2x plus 1 equals 0, 2x equals negative 1, x equals negative 1 over 2. That is that. Okay, so I guess you could say we've struck it lucky, but this is a way of short-circuiting some of the drama of trying 1, negative 1, 2, negative 2, as you would with factor theorem potentially. And it's entirely possible that some of these may not turn out to be satisfactory candidates. So you could potentially be wasting your time, and you've missed the fractions. And it turns out that a fraction is a solution to this. Okay, so where do we take it from here? Well, it's either long division or synthetic division. It's your call. I've done long division for this. So I've divided 2x plus 1 into my original cubic. What do I have to do to 2x plus 1 to get 2x cubed? Multiply it by x squared, subtract, I get 10x squared plus 17x. What do I do to this to get this? I multiply it by 5x, giving me 10x squared plus 5x, and I subtract that, leaving me 12x plus 6. What do I have to do to 2x to get 12x? I multiply it by 6, subtract, I get a remainder of 0. So my factors for this this cubic are as follows: x squared plus 5x plus 6, and this is readily soluble. That is x plus 3, x plus 2. So if we tried 1 as a solution, or we'd started at the other end and tried 6, we'd have been out of luck. Had we tried 2, we would have been in luck if we'd hit negative 2. That would have been our first breakthrough. Anyway, so I hope that that makes understanding rational root theorem a little easier. It tends to be featured in some courses and not others. Anyway, so those of you who strike it and are confused, that's what it's about. Thanks very much for watching. If you enjoyed this and found it useful, don't forget to subscribe. See you next time. Bye.